here. Okay, so the thing about the happy minutes, we're well into trigonometry right now. In fact, probably today or even the next day, I'm going to go ahead and introduce you to the unit circle. So, things are going to start to progress, and I want to make sure that as we go through, you guys feel as comfortable as you can. For a lot of people yesterday, I think it was kind of an eye-opener, and I'm not just talking in this class here, even in my pre-cal IS classes, there were several people who didn't know any of those 6 trig functions. They started off with zeros as well. Okay, so do not let that bother you. Anything, whether it's sports, playing an instrument, video games, whatever. If you want to get better, you do what? Yeah, you practice, and that's all this is. That is all this is. Okay, so, a couple of times it's probably going to be frustrating. I'm always going to give you what I feel is appropriate amount of time for whatever I ask you to do. So when we start looking at some math problems, you're going to get a little more time. But later in the week, definitely by Thursday, Friday, we are going to go ahead and start looking at triangles with the side lengths, and then you'll give me the ratios with the numerical values. And, we'll start to progress. Okay? So it's going to be fine. It's going to be great. And, they're happy, so everybody's happy. Andrea, you look happy. Go very quickly, very quickly because we haven't started yet. Okay, so a few things before we go ahead and get started, because I'm not showing you the unit circle today. That's going to be later. We almost finished up with the notes yesterday, so we had one problem, and I want to go ahead and take today to work on the assignment, because the assignment's going to be due tomorrow. I want to work a couple of problems with you. I want to, slow down, make sure that you guys feel really comfortable with this. Hey. Oh, get a paper? Yes. If you weren't here yesterday, right over there should be in Monday's folder, a copy of the assignment. Okay. But just a couple things before we go ahead and get started. Remember on Thursday, this material that we're currently on, the homework that's due tomorrow, you got a quiz over that. So linear and angular velocity. I'm sorry? Oh, the notes. The notes, I gave those last week, so they would probably be in Thursday. Yes, here they are. So here are the notes. But the homework given yesterday would be in Monday.
No, I just need the homework.
You just need the homework? Then that would be in Monday. There you go. All right. Okay, so you got that quiz coming up. Like I said, it's going to have linear and angular velocity on there, which, again, we're going to continue to practice today to make sure you feel good. You can use your notes on the quiz. That is never an issue. It's also going to have area of a sector, arc length. Let's go ahead and write down those formulas real fast just to make sure we remember them. Whoa, that was weird. That was real weird. Arc length. Okay, what was arc length? I know it was S, but at S equals what? Okay, the radius times theta. The only thing is that theta has to be in radians. You just have to convert it if it's not already in radians. For the area of a sector, okay, that was A equals, what was that formula we looked at yesterday? 1/2 the radius squared times theta. Again, theta has to be in radians. Okay. And then we were talking about angular and linear velocity. So angular. Are you all done? Okay. Thank you so much. All right, so I'll put that up in just a second. So angular, that isn't in. We use that curvy W omega for this. Now this is the word problems we were looking at. So even if you're not asked for angular velocity, I recommend finding it anyway because you need that in order to find the linear. So we always start with what fraction? Number of revolutions. Number of revolutions over time. Okay, every problem is going to start with that. It rotates how many revolutions in seconds, minutes, hours, whatever. Now, we like our angular velocity to be in radians. So, Nathan, what is it? Okay, so 2 pi radians over 1 revolution. The very first thing that should always cancel are going to be the revolutions. Okay, so you're going to have radians per time. That right there is angular velocity. Okay. Now, if I want to go ahead and find linear, okay, which is represented by that v, I'm going to take the angular and do what? All you got to do is multiply it by the radius of the circle. That's exactly right. Because the radius is going to be some length, the radians are just going to kind of disappear. Okay, this is what we've been talking about since last week, angular and linear velocity. Okay, good. Well, the only other thing that I want to go ahead and bring up before we actually get into a problem, the exam is next week, so it's definitely going to cover this material and probably some material from the unit circle as well, because we'll definitely have seen it before the week is out, and then we'll go ahead and start looking at that lesson next week. Next week's going to be a short week because you have a 3-day weekend. Okay, so that's, really nice. Yeah, you don't come on Monday, so we won't be here at the very least. Hey.
Hi.
Us teachers on that day, we have what's called content focus sessions. So we get together with other teachers from across the district and we plan and collaborate and do all that good stuff. But you guys will have the day off. I'll see you again on Tuesday. All right. So there we go. That, in a nutshell, is what we've been talking about. The exam is next Thursday, the 25th. In 2 days on the 18th, that's when we're going to have the quiz over this material. So both the quiz and the test will have the same stuff on it. Okay. So let's see here. What is the length of an angle of 1 second on the Earth? So we're going to go ahead and work this one actually very similar to what we did in the previous problem. We had the conversion yesterday that 1 minute was equal to 1 degree, is equal to 60 minutes. So then we were able to convert it. Remember, we went ahead and divided through by that 60. So I see that 1 minute is equal to 1/60th of a degree. Well, we're going to go ahead and do the same thing here for this next one. Okay. Yeah, so it's 1 degree is equal to how many seconds? 3,600. So 1 degree is equal to 3,600 seconds. All right. So theta, let me draw that, is equal to. Now, see, I want theta in degrees. Right now, we're looking at 1 second. So I need to make this 1 second. So what can I do to 3,600 to make him 1? Yeah, just divide him by himself, right? Anything divided by himself is going to be 1. So I'm going to do the same thing over here. So there we go. See, there's the 1 second. So now I know that 1 second is equal to 1/3600th of a degree. 1/3600th of a degree. Okay. But I went ahead and put a little times there because if we're looking for arc length, I mentioned it a little while ago, but I'm forgetting it again. It has to be in radians. Okay. So we have it in degrees. What do I multiply by if I want radians? Pi over 180. There we go. And you'll notice the first thing to go, the degrees are going to cancel. And if I'm remembering correctly, if you go ahead and multiply that out, 3,600 times 180, I want to say it's 648,000. Is that correct? You guys can help me double check that on the calculator. And speaking of, got quite a few things up. Let me go ahead and pull up my calculator. Okay, so do I need to go ahead and plug it in, or do you guys agree with me? You agree with me? Thank you, Nathan. Appreciate that. Okay, so all I need to do now is just go ahead and plug it into my formula. We're looking for the arc length S. Well, that's equal to the radius. Now remember, what was the radius of the Earth they were giving me? 3,960 miles. And we're going to multiply that by our radians. Pi over 648,000 radians. Okay. But again, since we're multiplying it by a unit of length, the radians are just going to disappear as they normally do. So we just need to figure out, what that is. So 3960, let me come on over here. 3960, parentheses, control divide, we had pi over the 648,000. Okay, so when I go ahead and push enter, so let's say about 0.019 miles, or about 0.02 miles. Okay. So about 0.019 miles. Now, let me go ahead and take this out real quick. That's for the homework. We'll talk about that in just a second. But let's say I wanted to convert this into feet. Okay, so I've got 0.019 miles. Okay, so Brandon says I got to put miles down below because I'm going to want those to cancel. So in 1 mile, there are 5,280 feet. Now, you'll notice I went ahead and rounded it 0.019 just so I could put that on my paper, I could show my work. But going back over to the calculator, I'm going to take the full decimal, and that's what I'm going to multiply by 5280. That's going to give me a more exact answer. So when I push enter, I'm saying the same object that traveled about 0.019 miles is equivalent to, let's say, 101.4 feet. 101.4 feet. And there we go. Okay. What do we think? Easy? Okay. Now, the rest of the time is just going to be for homework. So, I will work some problems with you if you like. Do we want to go ahead and maybe work one problem from each section to kind of set the stage?
Yeah.
Okay, yes, ma'am. Number 2.
So like, it doesn't give you pi, so you just pi is not.
Now, we are given that it's radians, so it's just 0.5 radians, yes. So sometimes the radian measure can be given with pi, or sometimes it can just be a fractional or a decimal value. That's perfectly fine. But typically a big indicator is that it'll have pi with it. But here we are given as radians. So out of these first 4, which one would you like to do together? Number 1 or number 3? Okay, so which one do you guys prefer? Well, I'll tell you what, I'll do one, and if somebody wants to come up here and work the other one, I'll be okay with that. You want to start with 3? Okay. So what we're doing here says use the arc length formula, so we want this guy here, to find the missing quantity, round answers to 3 decimal places, if possible, because some of these aren't going to do that. Okay, so, and if it helps, go ahead and draw yourself a circle. So we've got a circle with a radius of 3 inches, and we've got a theta measure of 120, so that's definitely bigger than 90, so not the majority, but definitely more than a quarter. Okay. And we want to find the arc length. So the arc length created by that central angle. Well, I've got everything I need, but we actually mentioned this a few moments ago. We need to make sure degrees are in radians. So 120 degrees over 1. What was it again? I keep forgetting. Pi over 180 degrees. So see, these degrees are going to cancel. Okay. And that's going to be 2 pi over 3. I would agree with that. Okay. So I have my radians in for my theta measure. I got the radius. All I got to do is plug in. So the arc length S is equal to 3 times the 2 pi over 3 that we got right there. Now, we can go ahead and plug it in the calculator, but hopefully you're immediately going to notice those 3's are going to cancel. So 2 pi, we just go ahead and type it in. Let's get the decimal approximation. So it wants it to how many decimal places? 3. So 6.283. Okay. So 6.28. Now 6.283 what? Inches. Because remember, we're multiplying inches by radians, and it's another one of those cases where as soon as you introduce a length, the radians just kind of disappears. Okay. Okay, so there we go. There's number 3. Did somebody want to come on up and show me number 1, or do we want to move on to the next section?
We can
Do the next section. Okay. All right, and maybe, someone will change their mind. Come on up. Work that. Number 1, let's see here. Yes, I would just go ahead and keep it in radians. Because the only way this formula is going to work is if theta is in radians, so the answer you get should immediately be in radians. Okay. Now numbers 5 and 6, find both the arc length and the area. Round answers to 3 decimal places. Okay, so do we want 5 or 6? 6, okay. Now this one here, they're not saying that this is pi over 6. It's just that the pi over 6 wouldn't really fit in there. They're saying that is your theta measure. Okay. So let's just go ahead and set it up. We're going to be using these 2 formulas. The arc length is equal to the radius times theta. And the area is going to be 1/2 the radius squared, again, times theta. Both of them got to be in radians. Okay. Well, we got a radius of 3 meters. So S is equal to, the radius is 3, times, it's already provided to me in radians, so I don't have to do anything extra. So times pi over 6. Now, 3/6 pi would actually be pi over 2. I mean, you could go ahead and reduce that before plugging it in the calculator, but it really doesn't matter. It's going to give you the same result. So let's see, what is pi over 2? Okay, pi divided by 2. What would I put to, how many decimal places? Was it 3 again? 1 point what? 571. 3 decimal places is what we call the nearest thousandth. So 1.571, and I believe it's meters. Okay, so there's 1. Okay. So on these, they're just using formulas, just manipulating. Okay. You'll have a couple, ones like these on your quiz. Now let's find the area. So again, I have everything I need. I'm going to take 1/2 times. Well, what is 3 squared? 9. Okay, so times 9, the radius squared, times theta in radians, pi over 6. Okay. And this can simplify. We can go ahead and get this as a product before we even start, or just go ahead and type the expression into your calculator. 1/2. Now I'm going to go ahead and do this. Instead of putting in the 1/2, I'm going to go ahead and start with I'm just going to say 0.5, because it's the same thing, right? Times 9 times control divide. Let's see, we got pi. I believe it was over 6, right? There you go. Just multiplying the whole thing out. What should I get? Okay, I heard 2.356. That is exactly right. So 2.356. Meters what? Meters squared. Yes, because we're talking about area. There we go. And then if we were talking in volume, which we are nowhere near yet, but that would just be meters what? Meters cubed. Yeah. Okay. So how are we doing so far? Pretty good? Not too bad? Okay. All right. So this first page right here is just working with the formula. That's it. Okay, that's it. All right, so let's see. We got a couple of word problems, starting with number 7. So the next 7 are word problems. So let's work a couple of these together. Which ones? You do want to do 7? Sure. Okay. Now, the one thing on 7, you remember yesterday, for number 7, we want to make sure that our angle is in degrees. On number 10, you want to make sure to give your final answer in what? Miles per hour. And then on number 12, my hint to you was I created a system. I thought that was the easiest way to solve it. And I went ahead and provided you a little diagram to kind of help you out. Okay. All right, so let's take a look at number 7. It says a strawberry farmer needs to water a strawberry patch of 1,500 square yards that's in the shape of a sector of a circle with a radius of 40 yards. Okay, so let's just go ahead and draw a circle. So let's say we have, a circular plot, and we're going to water a sector where we already know the area is 1,500 square yards. Okay. And all we're trying to do is find theta. In fact, we know that the radius is 40 yards. Okay. Well, what was the formula again for area? 1/2 the radius squared times theta. Okay. Well, let's go ahead and start here. What is 40 squared? 1,600. Okay. All right. And we already are given that the area is 1,500. So 1,500 is equal to 1/2 times the 1,600 times theta. I'm sorry? And absolutely, we can go ahead and take care of that. So what's half of 1,600? 800. Okay. So 1,500 is equal to 800 theta. So how would I solve for theta? Oh, subtract? Divide. There we go. That's the opposite of multiplication. So I'll divide 800. 800. See, those are going to cancel. And see, now this one's actually pretty neat. You can cancel out pairs of zeros because the common factor actually turns out to be 100. So theta is 15/8. No, can't reduce that any further. They don't have any common factors. I mean, you could put the decimal if you wanted to. Okay. Now, here's the question, though. 15/8 what? Is that degrees or is it radians? It's in radians. See, we used the values provided with the formula. The only way that formula works is if theta is in radians. So on this number 7 right here, I wanted you to make sure your answer was what? In degrees. So all I have to do is take this 15/8. I want to multiply it by 180 over pi. Yes. Okay. Because we've solved the problem, we just now need to make sure that our answer is in the correct form. Is everybody okay with what I'm doing? So let's see here. I'm going to take 15/8. 15/8. Okay, let's get out of here. Parentheses, parentheses. And I'm going to go ahead and divide that 180 pi. Okay. So somebody help me out. What am I going to see when I push enter? Okay, 107.43. That's perfect. That is in degrees. You know, on this one, the problem didn't specify, and neither did I. So if you said 107, I'd be okay. 107.4. Okay. If I don't specify, then I guess it's dealer's choice. Okay. And that's it. There you go. Bam, 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 bam. That's number 7. Okay. So now one more. I'll go ahead and work with you. For Andrew? I'm sorry? Okay. So we're not in the middle of a lesson, so I'll go ahead. Yeah. Pass it right over there. 12 is what you want? Okay. 12 is a good one. I would probably say that out of all of them, 12 is, I don't want to say the most difficult. I'll say the most fun. There you go. Okay. Now, would you guys like the opportunity to try it? First period. Try it on your own. Okay. Or maybe I can just kind of set it up for you and see if you can carry it to the end. Okay. Let's do that. Let's do that. Now, you remember I said this one was really easy, or much easier, I felt, if you solved it using a system. So I went ahead and created a little diagram here to help you out. It says it takes 12 identical pieces to form a circular track for a pair of toy electric race cars. So has anybody ever worked with or played with one of those slot car sets? You know, the curved pieces, you go ahead and just click together. And okay. So we're talking about 12 of those would form a circle. Okay. So 6 above, 6 below. If the inside arc of each piece is 3.2 inches shorter, that's going to be important to helping me create my system. Then the outside arc, what's the width of the track? Okay. So why don't we go ahead and start here. What's the formula for arc length? Oh, now that's linear and angular. That's something different. S equals r theta. Okay, so for this problem, we're going to go ahead and base everything off of S equals R theta. Okay, now do we know what the angle measure is? Okay, well, let's see. It says we're going to form a circular track. And how many pieces of track are there? There are 12. Okay, so we have 360 degrees because the track is going to be a full circle. And we're going to break it up, into 12 pieces, right? Okay. So the angle for each one of these, what is that? 30. 30 degrees. Now, why don't we go ahead and do this? Because for this formula, it has to be what? It has to be in radians. So why don't we go ahead and convert that? Does anybody know off the top of their head right now? Okay. Or yeah, think about it like this way. 1 revolution in radians is 2 pi, right? And we've got 12 pieces. So what does 2/12 become? 1/6, yeah. So this is pi over 6. So 30 degrees is pi over 6. Or we could have taken the 30 and multiplied, by pi over 180. It's going to give me the exact same thing. So now I know this is pi over 6. Okay. All right. So I started by thinking, okay, we're talking about arc length, right? So I went ahead and created an expression for each of these 2 arcs. So the longer outside arc I called S sub 2, and the shorter inside arc I called S sub 1. Remember, X is what we're trying to find. We want to find how wide each piece of track is. So for S sub 2, okay, I said that's the radius. Well, this arc corresponds to the entire diagram, right? So that would just be R times pi over 6. Now let's do the same thing for S sub 1. But where S sub 1 is right here, okay, what would be its radius? Oh, no, we don't know. Now we know the difference between them is going to be 3.2. There you go. We take the full length of the radius and subtract off what we want here. So wouldn't this little piece right here be R minus X? So that's the radius for that inside arc. R minus X, again, times theta pi over 6. Okay. Now, this is where the system is going to come in. You remember how this 3.2 I said was going to be important? If the inside arc of each piece is 3.2 inches shorter than the outside arc. So I know that S sub 1, well, shouldn't it just be S sub 2 minus 3.2? Okay. Hello. Somebody left Cheetos. All right. So is everybody okay with how I got that? Okay. So it makes sense if I go ahead and take the difference, S sub 2 minus S sub 1, the difference between them should be 3.2 inches. That's what the second sentence is just telling me. So I just kind of worked it around, solved it for S sub 1. Because now take a look at what we have. Okay. Remember, we're creating a system, right? So does anybody notice what I can now do with this? What are both of these equal to? They're both equal to S sub 1, right? So what should I do with those equations? I should set them equal to each other. I know that S sub 2 minus 3.2 should equal R minus X, okay, times pi over 6. So now here's the good news. I got one equation. Okay, bad news, I've got 2 variables. Now, what are we trying to solve for? We're trying to solve for X, right? Okay, the uniform width. Okay. Well, if I could somehow find a way to get rid of R, then I could just solve for X because it's just a normal equation, right? Well, that's where this guy comes in. Okay. Because let me show you. Let's solve him for R. Well, let's just go ahead and multiply both sides by 6 over pi. Because dividing by a fraction is the same as multiplying by its reciprocal, right? Okay. So these guys are going to cancel. So I know that the radius should equal s sub 2 times 6 over pi. Well, now that I have an expression for the radius, I'm going to go ahead and plug him in there. Okay. S sub 2 minus 3.2 is equal to, instead of r, I'm going to put the s sub 2, what was it, 6 over pi minus x times pi over 6. Okay. Now you're probably thinking out there, well, we got another s sub 2, but it's going to be okay. Right, Daniel? Right, Daniel? Yeah. Right, Daniel? Yes, it's going to be okay. Let's go ahead and distribute. S sub 2 minus 3.2 is equal to, now I'm going to take s sub 2 times 6 over pi and multiply it by pi over 6 minus x times pi over 6. See, all I did was distribute it to both terms, right? Well, do you notice anything? What's going to happen here in the middle? Pi's cancel. The 6's cancel. So I've got s sub 2 minus 3.2 is equal to negative x times pi over 6. Oh, excuse me, I forgot one. S sub 2 minus x times pi over 6. Okay. Well, what happens now? What's going to happen if I try to combine the s sub 2's? Yeah, they're going to cancel. It doesn't matter which one I choose. If I subtract the s sub 2, those are going to drop out, right? So see, now I've got a negative 3.2 is equal to negative x times pi over 6. But since they're both negative, I can just make them both what? Yeah, just multiply or divide through by a negative. That's perfectly fine. So now I know that 3.2 is equal to some number x times pi over 6. Well, how did I solve for r just a second ago? I multiplied both sides by what? What do we call it when we flip the fraction? The reciprocal. So I'm going to multiply both sides by 6 over pi. See, those are going to cancel. There's my x. Well, no, because it's one product, so they're both going to have the same sign, yes. That's actually a really good question. So let's see here. I need 6 over pi times 3.2. So parentheses, control divide 6 over pi. Okay. Let's get out of there. Close parentheses, 3.2. Okay. Okay. And does this one say to round to a certain place? Okay, so let's just say 6.11. And we're dealing with what? Inches. Let me see what happened to my paper. So that one, I'm glad you guys did ask about that. That is the longest, most difficult one we have. Okay. All right. Okay. All right. Okay. So one like that, as far as like the test goes, the quiz, not going to happen. Okay. You know, I'm still going to try to keep the rigor up. I'm not going to give you anything like that. I guarantee even my IS classes, that's going to be a question asked tomorrow when we talk about the assignment. Okay. So I'll tell you what, we still have time. Let's go ahead and work one more. Because I want people to feel, walk out of here feeling like, oh my God, not horrible. Let's do another word problem. 10. 10? Is that what you guys want?
No, what's the second part?
Oh. I think the rest of them are all pretty much the same, and they're not too bad. That number 12 there was definitely the worst one. Okay. So you do want to do 10? Yeah. 10? Let's see, what was 10? Okay, so a car's wheel with a radius of 1.5 feet, okay, is spinning at a rate of 20 revolutions per minute. How fast is the car traveling? Okay, now remember number 10, we wanted what? Now, this is a linear and angular velocity problem. Okay, we know because we see that phrase revolution per time. So how do we always start these problems? Number of revolutions over the time, right? Okay. So when it's asking how fast is the car traveling, that's wanting to know the linear speed. Okay. So we have 20 revolutions in 1 minute. Okay. Now you can't find the linear without having found the angular. So how do I make this the angular? Okay. So Nathan says multiply it by 2 pi radians over 1 revolution. Because remember, what's the first thing that should always drop out? The revs. They should be gone. So this is my angular, 40 pi. That's radians per minute. There you go. As soon as I take the angular, all I have to do is multiply it by the radius. You've got your linear speed. So we've got 1.5 feet. So I'm going to put 1.5 feet over 1. Now here's the thing. I introduce feet, so the radians disappear, right? But it's in feet per minute, which would be perfectly fine, but what I want you to do for number 10, we want miles per hour. So do you want to change the minutes or the feet first? Okay, so the feet. So can anybody tell me what the full fraction should be? 1 and FT on the bottom. So 1 foot. So 1 mile is 5,280 feet. Okay, so now we have miles per minute. So I need to change minutes to hours. So it should go 60 minutes over 1 hour. Because the minutes will now cancel. I've got miles per hour. Remember, that's the dimensional analysis we were talking about last week. Many of the problems look like this. Okay, but I think this one might be the biggest. So in order to get the answer, I need to take 20 times 2 pi times 1.5 times 60, and then do what? Divide by 5280. So let's see here. Let me get rid of this. Document B. So we had 20 times 2 pi times, what was it, 1.5 times 60? Was that everything up top? And then I'm going to divide that by 5280. So how fast in miles per hour? I'd say about 2.14. 2.14 miles per hour. There you go. So definitely the ones on the front page, I don't think you're going to have any issues with. The other word problems, now that we've got the worst done, I think you guys are going to be just fine. I am going to be here in the morning, and I do want to apologize if anybody did happen to swing by. Hopefully you got my text. They pulled me into a meeting at the last minute, and they basically told me, you cannot say no. So I apologize. Now, you remember tomorrow morning was supposed to be the deadline for the retake. Because I got pulled into the meeting, the deadline to retake last week's exam is now going to be Thursday morning. Okay? I'm sorry because that was beyond my control. Hey, Brandon. Number 1 is in miles. No. Once you go ahead and solve that, it'll already be in radians. So we know that S is equal to R theta, right? So we already know that the radius is 5. We already know that the arc length S is 3.
Do you want us to simplify 3/5?
And that's the thing.
And is that all it is?
And see, here's the thing. Is that 3/5 degrees or radians? That's radians. But see, now it didn't say anything specifically, so I might just leave it as 3/5. But remember, what is that? Point what? 3/5 is 0.6. It did say to go ahead and, round it to 3 decimal places, so you could just say 0.600. That's fine. Now, if you want to convert that to degrees, that's fine as well. Okay. Guys, thank you so much. Appreciate it. Hope this helped. You have a great day. see you tomorrow.
Tony brought up my point. It's a bit humorous how they took the time to figure out all the other dimensions of that track.
Oh yeah,
Just use a ruler.
you could, yeah.
They took more
But don't you feel accomplished now that we didn't need that? Yeah, that one was pretty brutal. I'll admit
How
that
did
one.
you know all of that before knowing?
I don't know. Maybe they stayed on track. Nobody's here to laugh. Okay. You guys take care.